Okay, let's look at the first one. Oh yeah, before we continue on, for remedial later on, Miss Tan students, you all go back to your infinity room. For my students, we still have remedial. Of course we have remedial. We will all meet in the infinity room because this area is blocked off for the N-level exams. Okay, let's all meet at the infinity room first. Any questions? Okay. Same time lah. For my students, those who finish your lessons at 2:15, we start at 2:15 lor. Those who finish at 2:50, we meet at 2:50. Okay. Let's get started. Question 1A, part 1. The height is 5 cm. So just check your answers first. If you need me to go through, please stop me. For the first question, 1A and B. Is 4 intact here already? Okay. Alright, so for the first one, any questions? Any? No, then let's move on to question number 2. If there are not enough tables, go and grab from outside. There's one seat beside Roderick, one seat beside Farisha. Hurry up, hurry. For those who just joined us, we are going through our mathematical modeling paper. Pass to Brenda. Okay, does anybody have problems with calculating the road tax? $567. You know which row to be looking at, right? And it's just simple substitution only for 1300 cc. Okay, now next, part B, or part C, which is cheaper for Jack to use. Would it be cheaper for him to use other transport instead of his car? So show the working to support your answer. Clearly, we need to calculate how much does it cost for a year for the car, and then we compare that with public transport. So for a car, annual cost is equals to 70 over 100 times 2360. This is for the insurance. Then the other miscellaneous costs, 9201050 plus earlier on we calculated the amount he had for petrol. So rounded off it was 1963, right? Yep, 1963. And we still need to add the tax, which we also calculated to be 567. This gives us a total of $7,032. This is for the car. And now for public transport, it will be 50 plus 55 plus 375. This is for 1 month, and we multiply it by 12 to get the amount per year. This gives us 5760. Okay, now that I have this, how do I present my answer? I mean, it's quite clear, right? Which one is he should be choosing? Should be choosing others. So what we can do is, from here, we want to show that we are comparing. So show an inequality sign. This is less than 7032. This 7032 came from the annual cost for the car. So now we put in our conclusion. It would be cheaper to use other transport instead of car. Okay? So even though you may know mathematically what you should do, even though you may know in your mind what the answer is, you still need to present it clearly such that the examiner knows what is going through your mind. Part B. For the text. Okay, this one. So based on his engine capacity, which is 1300 cc, we are only interested in this line. Do you choose that? Okay. Then now, the text will be equals to 250 plus 0.375 times 1300 minus 1000. Then the whole thing is multiplied by 1.564. Then you get 567. What do you do? Okay. So careless mistake. Any more issues, questions for this? And next one, modeling. You have a tank for oil shown in the picture. So he wants to use a measuring rod to put inside the top of the tank to find the amount of oil inside. Okay. So select the shape he should be using. Cylinder lah. And he uses a capacity of 1200 liters. Is that the actual fact? The capacity of the actual one, 1235 liters. But for his model, he just wants to simplify it. Okay? So instead of using 1235 liters, he uses 1200 liters. And instead of the width of 1030 millimeters, in his model, he is using a width of 100 cm only. Okay, so a model just simplifies the reality. It makes things easier for us, helps us to visualize, understand the concept, what we should be doing in order to get the whatever calculations we need. So for this model, show that the length of the tank is 153 centimeters. Now we already know we're using a cylinder. So given that the volume over here, 1200 liters, and there is a width, this is the width of 100 cm. Then I want to calculate the length. Okay, so this cylinder is resting on its side, similar to this. So once we can visualize this, we can calculate this horizontal distance, which is the height. In this case, they call it the length. Okay. Then the volume of a cylinder is simply base area times height. In base area, the cross-sectional area will be that of a circle. Volume in 1200 liters is equals to 1200000 cubic centimeters. I changed it to cubic centimeters because over here my width is already in centimeters. I need to be consistent. So my final answer for the length over here, it will also be in centimeters. This is supposed to be equals to pi and the radius of 50 square times the length. So solve for length equals to an answer, round it off to be 153 cm shown. Okay, next. Give a practical reason why the length of the measuring rod should be more than 100 cm. This is the measuring rod. How does this work is that the rod initially is shiny. Then you dip it into the tank, which is filled with oil, which is sticky and black. You put it out, then you look at the amount, how much of the rod is stained with the oil. Then you know how much oil is there inside lah. Because it is not transparent, you can't look inside. So it's similar to car vehicles, the car engines. They also use the same way to check the engine oil. Okay, so now we know that we use a cylinder. So the cross-sectional area is actually a circle. The diameter in our model is 100 centimeters. So we know that this distance over here is approximately 1030 mm in the actual, and in our model it is actually 100 centimeters. So if the rod is shorter than 100 centimeters, are you able to go all the way in and pull it out? You can't. If you drop it inside, you can't get it out. So what is the reason? We can say that the height of the machine, height of the cylinder is 100 cm. This is based on our model. We also can call this the diameter. So the rod must be greater than 100 cm, cannot be equal to 100 cm also, so that it can be taken out. I'm not sure if you all can see clearly. Okay, so basically, the rod is dipped inside the tank, and this is the cross-sectional area. Currently, it contains 600 liters of oil. How many centimeters from the bottom of the measuring rod should Jim mark 600 liters? So very straightforward. We know that it is the halfway mark. Why? Because 600 is just half of 1,200 liters. When it is halfway filled, then the cross-sectional area will be that of a semicircle. That is halfway, the halfway point. So your rod, which is currently more than 100 centimeters, from the bottom up this distance to mark out the 600 liters will be half times the diameter, 100 cm, which is 50 cm. Please do not write 1200 liters equals to 100 cm. 600 liters equals to 50 cm. They are different quantities. One is volume, the other is for length. They cannot be equal to each other. They can correspond to each other, but they can never be equal to each other. So presentation-wise, take note. So now, he wants to mark 300 liters on his measuring rod. Can we use the same logic to say that, the halfway point over here is our 300 liters. Can we do that? Why not? Yes, the cross-sectional area has a different shape altogether. We are not dealing with similar shapes over here. Okay, because for similar shapes, we know that the ratio of area is just the square of the ratio of length. They have such a relationship. They are proportional. But in this case, we are not dealing with similar shapes. If it is at, okay, let's look at this point. Over here we have 50 centimeters. If this is 25 centimeters in height, then you look at this shape. This is not a semicircle. There is no direct proportion involved in this question. So, explanation, we say that the cross-sectional areas are of different shapes. Or you could say that the cross-sectional area narrows as the volume of oil decreases. Yes? Does not what? Volume of oil does not rise at a constant rate. I get what you're trying to say, but you are not using the correct phrases. Rising at a constant rate is talking about time. You're comparing it with time. With every 1 second, how much in height does it rise, so on and so forth. You can rewrite that, and then you can show it to me again. Okay, so next part of the question. Why do I have shaded area? Okay, so this is the shaded area. Yep. The shaded area is the area of sector OAB minus the triangle. Show the expression, blah blah blah. Okay. For the triangle, the radius is 50 cm. 50 cm. So area equals to half A B sine x degrees with the degrees. So you must have this. Now show the expression for the area of sector OAB. Okay, OAB, this is a sector. The formula, what is the formula for area of a sector? What's the formula? Half or a square theta. So what is this theta over here? It is the angle in radian, not degrees. We can use this formula, or I can use proportion, okay? So the area of one circle is pi r square. Then I multiply it by, using proportion, this is x degrees. So x over 360. Both of them will give you the area. Okay? So if we use this, the second one, we will get pi and r, the value of r will be 50 square x over 360. Then press your calculator. $21.8166. Oops, I forgot the x. So this is approximately 21.8 x square centimeters. Okay, anybody used the formula for half r square theta but did not get the answer? Does anybody need me to go through using this method, half r square theta, to show the area? Nobody? Nobody? Okay. Anyway, if you want to use this, you must know how to convert from degrees to radian. 180 degrees is your pi radian. So you use that one, direct proportion, you will be able to get it also. So now area of the shaded region, we just subtract lah. Sector minus triangle. So this will be 21.8x minus 1250 sine x degrees. This over here is a requirement, the degree. It is not optional. So volume of the oil equals to the cross-sectional area times the length. We already have an expression for the cross-sectional area. And the length was 153. Continue to simplify, and you get 3340x minus 191000 sine x degrees. Again, all the degrees are necessary. You do not have a choice. Yes. Okay, this one is rounded off. Okay, now part F. You need to refer to your diagram also. When it is containing 300 liters of oil, the value of X, the angle is 132.2 degrees. Then find the value of D, which is the distance from the bottom of the measuring rod. So meaning now X is equals to 132.2 degrees. And I want to find the value of D. What is the approach? You know, we don't often see questions like this with a story and everything. So you need to plan. What is the approach to find the value of D? You have a lot of formula that you memorized. But it's a matter of choosing the correct one to use. So what do you think? Okay, radius, 50 centimeters, what do we do with it? O to this part. Okay, so this is what I need you to be thinking of during your exams. You think that to find D, I could use the radius, then I minus O to the bottom of the triangle. It's logical. We know the radius already. So now the next problem is I need to find out the height of this triangle. And how do I do that? Because once I manage to do it, I will be able to get an answer. So that's the next problem to solve. How to find the height of this triangle? How? The rest? Cosine? Okay. I hear trigo, cosine, so on and so forth. Identify your right angle triangle. Okay, so from here, this is the triangle that I identify. It is a right angle triangle. Let me just draw it out so that it's clearer. Fill in all the information you have. This is your radius, so 50. What about this angle? 66.1. Now with this information, can we find the height of the triangle? Which trigo ratio do we use? So all this at the back of our mind, right? You might be thinking, cosine 66.1 degrees equals to your adjacent over hypotenuse. So let's call this the height. Divide by 50. Then now I can find the value of height, which is 50 cosine 66.1 degrees. I'm not going to evaluate it yet because I don't want to have so many decimal places and I don't want to round off. I don't want to make any rounding errors also. So with my height, I can now find the value of D. D is equals to 50 cm minus the height, which is 50 minus 50 cosine 66.1 degrees. Key in exactly what you have, final step, then you round off. And you should get 29.7 approximately. Okay, done. Then we move on to the last one. Write down the distance from the bottom of the rod to the 900 liters mark. Okay, so now we know for 300 liters over here, the height will be 29.7 cm. This corresponds to our 300 liters. Then the halfway mark, 50 cm, corresponds to our 600 liters. Then now if I want another 300 liters, which means a total of 900 liters, then this height over here must also be 29.7 cm. So the distance from the bottom of the rod to the 900 cm mark will be this distance, which we also can calculate because we know that the total height is actually 100 cm, right? Then since this is 29.7, then my yellow color height will be 100 minus 29.7. The answer will be approximately 70.3 cm.